Welcome to System Design Interviews, Episode 2. This is a mock interview, start to finish. I ask, you answer, and the whiteboard only fills up when the answer earns it. Today's question: Design Search Autocomplete. Here is your prompt. Design Search Autocomplete. A user starts typing in a search box, and underneath it we show 10 suggestions. They have to feel instant. Take as long as you need. Where do you want to start?
Before I draw a single box, I want to ask you 4 questions. Most candidates hear autocomplete and start drawing a search cluster. That is the mistake, and I think it is the mistake this question is built to catch, so the board stays empty for 2 more minutes. First question: how many searches a day? And does a request fire on every single keystroke, or does the browser debounce them?
100 million searches a day. Every keystroke fires, but the client debounces, so call it 5 suggestion requests per search.
Thank you. Second question: how fresh do the suggestions have to be? If a brand new phrase starts trending this morning, does it have to appear today, or is tomorrow acceptable?
Tomorrow is acceptable for the main index. Getting a trending phrase within the hour would be a bonus.
Third question: is the list the same for everyone, or is it personalized per user?
The same for everyone. Personalization is out of scope today.
Last question: how many suggestions do we return, and what is the latency budget for one keystroke?
10 suggestions. Under 100 milliseconds. End to end.
Good. Let me read that back so we agree. 100 million searches a day, about 5 requests each. The index may be a day stale. 1 global list, no personalization. 10 suggestions. And 100 milliseconds per keystroke. That is my contract for the rest of this hour. If any of those 5 lines changes, the design changes with it.
That is the right start. And let me tell you what I am actually testing, because it is not what people think. I am not testing whether you know what a tree is. Anybody can name a tree. I want you to notice that this is a read of an answer that already exists, and then design as if that were true.
Then let me put numbers on it first, because one of these numbers decides the whole algorithm. 100 million searches a day times 5 requests each is 500 million requests a day. Divided by 86,400 seconds, that is about 5,800 requests per second. Peak is maybe 3 times the average, so call it 17,400.
And how big is the thing you are reading from?
I do not index every query ever typed. The top 10 million queries cover about 95% of the traffic, so those are the ones I index. 10 million queries, sharing their prefixes, add roughly 6 new nodes each. That is 60 million nodes. At about 100 bytes a node for the 10 completions and the child pointers, that is 6 gigabytes. 6 gigabytes fits in memory on a single machine, so this is not a storage problem either. Here is the number that decides everything: 100 milliseconds, end to end. The network round trip eats about 40 of them. That leaves me roughly 50 milliseconds inside the service, per keystroke, at 17,000 requests a second. Walking down a subtree to find the best completions does not fit in 50 milliseconds. Reading a list that is already there does. Now I will draw a browser and one suggest service. The service does exactly one thing. It takes a prefix and it returns 10 strings. There is no write anywhere on this path.
And the store. It is a tree, held in memory. Every prefix is a node on a path, so typing D, then A, then T is not 3 searches. It is 3 steps down one path. What the user has typed is literally a position in the structure.
Why not put an index on a queries table and run a like prefix %? We already run Postgres.
Because of the read path, not because of taste. A B tree finds the prefix range, and that part is genuinely fine, but then I have to rank what is inside that range at query time on every keystroke, and the popular prefixes are exactly the ones with millions of rows in range. That work lands inside my 50 milliseconds. The try lets me move that work to last night.
Which is the whole trick. So let me say it slowly. I do not walk the subtree at query time to find the best completions. I store the finished top 10 list on the node itself. You land on the node, and the answer is already sitting there. That is a lookup, not a search.
And where does that ranking come from? What makes one completion better than another?
Real query logs. A batch job takes yesterday's queries, counts how often each one was actually typed, weights the recent days more heavily, and builds a fresh tree with a new top 10 list on every node. It ships that as one artifact, and the service loads it. The ranking is not alphabetical, and it is not computed live.
At 17,000 requests a second, what breaks first?
Not the total, the skew. Those requests are not spread evenly over 60 million nodes. Single letters and two-letter prefixes are an enormous share of them because everybody types them on the way to somewhere else. So I put a cache at the edge, in front of the service, keyed by the prefix. A few thousand prefixes carry most of the traffic, and the cheapest requests never reach my service at all.
And what does that cache cost you?
3 things, and I will say all 3. 1. Staleness on top of staleness. The index is already a day old, and the cache adds minutes on top. That is fine here. It would not be fine for a stock ticker. 2. A cold cache after a deploy sends all 17,000 at my service at once. 3. And this is the one people miss. If the edge answers, my service never sees that query. So the log I rank on tomorrow cannot be my service log.
Which is why the logging is its own path. The search box logs what the user actually searched, not what the suggest service happened to see, and it writes to a stream, one way, off the hot path. That stream is what tomorrow's build reads. Nothing on the serving side ever writes into the index it is serving from.
Then here is my last one. A phrase starts trending at 9 this morning. Your batch job runs tonight. What does the user see all day?
The wrong thing if I only have one index. So I run 2. The big tree from last night, and a small hot layer rebuilt every few minutes from the last hour of queries, holding a few thousand prefixes at most. On a read, I check the small one first, then fall back to the big one. Merging 2 ranked lists of 10 costs nothing, and it fits inside my budget. And I still never mutate the big tree in place. I replace it whole when the next build is ready.
That is the answer I was looking for. You saw that it was a read, you moved the ranking off the hot path, and you kept every write away from the thing you are serving from. That is episode 2. If this was useful, hit like and subscribe for the rest of the series. The written version of this question, with the 4 clarifying questions and the trap, is on the blog.